Okay, so we're continuing on in periodic behavior. This is called sign language. Our focus for today is to write a trig function. Trig means sine, cosine, tangent. Function just means you have y equals to something x or f of x to model a context. So we're going to be talking in word problems. How can I determine the vertical height of a rider on a moving Ferris wheel? So we already know how to do this part, but here's it, they're going to change it in such a way that they've added a layer onto your problem. Okay. So in lesson one, you probably found Carlos's height at different positions on the Ferris wheel. We just talked about this, right? Using right triangles as illustrated in the diagram. Recall the following facts from the previous lesson. Number one, the Ferris wheel has a radius of 25 feet. That's why the 25 showed up in that equation. And the center of the Ferris wheel is 30 feet above the ground. Carlos has also been carefully timing the rotation of the wheel and has observed the following fact. Okay, so this is old information. Here's where they layer new information. The Ferris wheel makes one complete revolution counterclockwise every 20 seconds. So let that sink in for just a second. Okay, so here's your Ferris wheel. You should know a couple of the things from last time. It's 30 feet off the ground. The center is 30 feet off the ground. The radius is 25. And they just told you that for A to go from here all the way around, how long does that take them? How long does it take for the Ferris wheel to do that? To go all the way around. Very good. 20 seconds. Perfect. So the reason why you get 20 seconds is now they're going to add some information. So how high will Carlos be 3 seconds after passing position A on the diagram? 3 seconds. Well, if it was, say, 20 seconds, I could do that, right? Because 20 seconds means I go all the way around. It would be exactly at point A, right? But they didn't ask for that. They asked for 3. 3 seconds, right? So how are you going to do that? Okay. So I want you to think about this. There's nothing new to this problem. As long as you kind of understand, like, if it takes them 20 seconds to go all the way around, maybe it would be a good question for you to ask is, okay, well, where do you think he'd be about B here? Right? So I want you to think about that, and then we'll come right back to figure this out. Okay, so the 3-second thing was very interesting. So I asked all of you guys, and most of you said it has to be somewhere between B and C. And the logic behind that makes legit sense. So if the whole thing takes 20 seconds to go all the way around, right? And let's assume that this is a pretty nice Ferris wheel where it's not rickety, where it goes fast in one section and then it like almost like stops when it gets to a certain section, right? It's a smooth ride. It's a consistent ride, right? So you remember back in 7th or 6th grade, you learned that if the whole thing takes you 20 seconds, you can figure out how much each section takes, right? By dividing. So that's what you first did. A lot of people first said, okay, fine, Miss Johnson. And here's where I'm going to encourage you to use, this in math, it's called attending to precision. Use your units to make sure that you're right? So 20 seconds divided by 10 sections equals 2 seconds per section. So when you have a 2 floating out there, right? Like pretend you just wrote the number 2. A lot of people lose what that number actually means. So if you keep it labeled like this, it'll make sense to you later on when you do like part E of the same problem. Okay. So that's piece of advice number 1, 2 seconds per section. So I'm going to label that here. It takes them 2 seconds to travel from like point C to point D, or E to F, or whatever you want. Okay. The next thing you said, well, if this is 2 and this is 4, well, shoot, we passed it. If you consider this to be a circular number line, right? 2, 4, 6, 8, 10, and so on, you would realize that 2, 4 means that shoot, it's somewhere here. And it's not somewhere here, because the question I'd ask is like, hey, do you think he'll be closer to B or closer to C at 3 seconds? And you should say he's smack in the middle. So smack in the middle means somewhere right here, right? So in reality, you want to find out this height, right? This height here. You want to find this height here. Because once I figure that out, then I'm done. So notice I can't really do anything with the whole height. But what we learned from last time was that we could do this by drawing a reference triangle. So whenever you have a point on a circle, you can always draw your reference triangle. And your reference triangle goes like this. From the point to the x-axis, take the elevator. Take an elevator down, take the elevator up. You can only go up and down in an elevator unless your name is Charlie from the Charlie and the Chocolate Factory, and his elevator goes all kinds of ways, but I don't have one of those, so I'm just going to go up and down. Students do this wrong, and they like to go across to the y-axis. Don't do that. Elevators only go up and down. So take it down to the x-axis. That's part of your triangle. You should already see part of your triangle. Does everybody see part of your triangle? That other side goes to the center of the circle. Your classmates explained this very well. And then you have this right triangle here. So your job is to not only be able to work with right triangles, it's also to find the right triangle in the picture, right? And sometimes he's not drawn for you. You're supposed to draw it for him. So one more time, what did we do? You all figured out that it took me 2 seconds to go from each point to each point, right? To advance to the next like little marker, I guess you could say. Then you said, okay, well, I know that if it takes 2 seconds for each one, that means 3 seconds will be somewhere in between B and C. Because the question was, how high will Carlos be 3 seconds after passing position A? So he passes position A, the clock starts ticking. 1, 2, 3. 3 is smack between 2 and 4, so I drew him as best as I could in the middle. Then whenever you have a point, you're always going to draw your right triangle. Take the elevator down to your x-axis or up, depending on where you are, and then draw your from your point to your origin, and then that's it. This angle in here, I'm always going to call him theta. Everyone say theta. Theta. It's a Greek letter. It's just the th sound, right? Theta is always used for our angles. So is alpha and so is beta. This is how you draw the letter alpha. So I'm going to write this. This is our little key here. This guy's name is theta. This guy's name is alpha, as in alpha, like alphabet. Beta looks like this. Just do your best to draw them. This looks like a 0 with a line across it. Alpha kind of looks like an A if you really look like it, but you start at the top and then that's how I draw it. Some books draw it more like that ish. I don't know. Just do your best, right? No, these are almost like variables. Very good question. Someone said, hey, do these letters belong to certain angles? No, these are just variables. So think about this as X or Y. But whenever we talk about angles, we tend to use these Greek letters just so that we have more access to things. Okay, so that's theta there. Okay, so back to our question. How high will he be? So looking at this, what do we already know? And one of you said, hey, Ms. Johnson, we know that the hypotenuse is 25 feet. So I'm going to label that in there. Very good. And then the other thing that you guys remembered was that this guy is, the center is 30 feet from the ground. Okay, so I already know that part. I just need to know this height here. So I will call him H. And what I really want to do is I really want to copy and paste this triangle and pull him out just so that we can just look at him and not the whole picture, right? So once you have your picture, then I almost like ditch the picture and only look at my triangle. Some of you are going to get so good at this that you won't need to do that. That's where I'm pushing you towards. Okay, that you don't need to draw another picture. If you need to, great. Okay, so looking at here, what can I use? What can I do? What is the thing that I'm going to be looking at? What am I going to be looking for now? What is the deal? How am I going to find H? So the other thing that you guys all discussed was you figured out theta. And I forgot to explain this because you guys all were having a good discussion on this. So can someone remind me how we figured out theta? Like I can copy and paste one of your classmates' really good explanations, but can you tell me how would I find theta? What was that formula that you guys all figured out? All right. Yeah, I'm going to copy the recent one so I don't have to scroll all the way through my chat because that's like all the way up there now. So credit to that other human who taught you all. I'll be like referencing that over and over again. If you don't know what I'm talking about, scroll back and copy that and put this in your notes. If this is the part that's going to make you confused, I would put this in a bubble. So when Ms. Johnson took notes as a college student, not as a high school student, because as a high school student, I'm just going to be honest with you, I didn't really know how to take notes. If this is the part that like caused you to be like, what the heck are you talking about? Put a little bubble around him. So that way in your notes, you have attention to him. So let's just describe where all these numbers come from, because all of a sudden someone says, where does 360 come from? Where does 10 come? Where does 36 come from? Why are we dividing by 2? And then why do we have 18 and then add it to 36? Like, where did all these numbers come from? So let's do a little like investigation. Where's the 360 coming from? Very good. 360 is it's the degrees of a circle. So for anybody who watches any of the like extreme sports, when they're like, oh man, that was a sick 360. I can't talk like you guys. That means they spun around, they did a complete circle, right? They started facing you, they spun, and then they ended facing you. That's called the 360. Half of that would be called a 180. 1.5 of that would be called a 540. 2 of those would be called a 720. If you watch extreme sports, they'll tell you. And it's kind of funny too, because when you watch them, like because they go so fast, I can't count them. But the people who are watching live can count them. I think that's really neat. I don't know. That's a skill that I don't have. All right, moving on. So 360, because there are 360 degrees in a circle. This is my shorthand for circle. It's a little circle with a dot in the middle. That's how we write circle in math. Everybody good? Good. So I got a bunch of people saying, oh, I get it. Why 10? Why 10? Where did the 10 come from? Very good. 10. This is people like, oh, I was like, is that a word? But someone just spelled it wrong. I was like, oh, that's not a word. Okay, so points. So someone says 10 points. Someone says 10 sections. So I know, sorry. I thought it was a word that I didn't know. 10 positions, 10 spokes. I say 10 pieces of pie. Do you guys all see my pieces of pie? I eat pie. I like pie. So this is whatever you want to say. I'm going to go with 10 sections because I think that makes sense. Or whatever, 10 partitions, 10 parts, 10 pieces, whatever you want to call it, 10. So why did we divide by 2 though? What happened with this 2? Where did this 2 come from? So in math, if you can describe where each of the numbers come from, you get it. Very good. So we took a piece of pie and we cut it in half, right? Cut pie in, piece in half. Section to get to the, you guys called this the middle. I'm going to use your words, middle. Okay. Let me go a little smaller so I have more notes. So the other part, and then we had, so then they said, then we have 18, and then we have 36. So are you comfortable with that? Some other people say then we multiplied by 3 because there's 3 of those half pieces in there. Whatever you wanted to do. They decided that each of these reference angles from the center here are 36 degrees. And then they added half of a piece, which was 18, which gave us 54. So this angle theta is not, I can actually label him as 54 degrees now. So I will say theta equals 54 degrees. So I'm going to erase this so I have an actual picture. Oops. Very good. So now you have this triangle. Now I need to find H. This is old stuff. Your brain should go like this. Hey, right triangle. I could use Pythagorean theorem on you. No, I can't because I don't have enough sides. That means I must use trig, which is sine, cosine, or tangent. Or you guys can also use law of sines or law of cosines. In this case, I will probably use sine, cosine, or tangent because I do have a right triangle, right? Although one of your classmates' favorite is law of sines, regardless of this being a right triangle or not. And I'm trying to think of if that is a disadvantage, but I can't think of the disadvantage. So yeah. So yes, we will be using sine. Yes, ma'am. We will be using sine. So go ahead and write that equation in there for you. This is practice. Get your practice in. Write your equation right now. I'm going to wait a couple seconds. $54. Actually, good question. So this 54 is from it's so one piece of pie, this guy here, from A to B, right? This angle in here would be 36 degrees. And then the angle from B to the point that we want would be 18 degrees. So 36 plus your 18, right? Good job. Good question. Okay, so you should have written an equation. What's your equation? Give me your equation. Okay, yes, I will explain that, sure. So yes, very good. Sine of 54 degrees equals to h over 25. Go ahead and solve that. I'll go back to the 18 in just a second. Let me finish solving this. Oh, very good. Someone answered it in chat. Very good. So then if I solve for h here, I'm multiplying both sides by 25. 25 here. So we get 25 sine 54 degrees equals to h. Go ahead and plug that into your calculator. So one more time, if you're lost on the 18 here, we took our whole circle and we divided it into 10 sections. So we got 36 degrees, and that's 36 degrees per section from A to B, B to C, so on and so forth. Okay, but then I wanted to go half a section, so that's why we divided it into 2, and that's why we got 18. So if you go from B to this point here, which I haven't labeled that point, maybe point P, just so I can talk about it. Or maybe I can't call it point C because I already have that. So P, where Carlos is right there, right? That's 18 degrees, but I don't want this little tiny angle from P to B. I want to go from P all the way to A. Very good. Very good. So someone says, hey, Ms. Johnson, I think I got the answer. So, of course, don't forget to, you know what I'm talking about. Everyone, I clicked on the wrong button. I clicked on the wrong button. Boo. Don't forget to click on the correct button. What button am I talking about? Don't forget to click what? What am I referring to here? So I got 20. Very good. 25 sine 54. That's the wrong answer. This answer doesn't even make sense, right? Because look at him. How could he be negative? Okay, thank you. That was a lot. Um, he can't be negative, right? And it's like, oh, it's because I forgot to hit degrees. Ta-da! It's 20.2, right? So 20.2 is my answer. Not my answer, rather. The H. H is about 20.2. And I'll put feet to remind you. And if you keep your units in here, the answer is feet. H is in feet. 25 is 25 feet. Sine 54, I don't know if I've ever talked about this. This doesn't have a measurement. Oh, sorry. You're so funny. I'm sorry your chat is messing up, hon. It's okay. That's okay. People needed a good reminder of what that was, right? We can all say thank you. Thank you. Okay. So I don't know if I've ever told you this, but sine of 54 doesn't have a unit measurement. It's not like inches, it's not like burgers, it's not degrees, it's not anything. It's a ratio of sides. So it doesn't have like a unit of measurement. Does that make sense? So feet times a number is going to give you feet. Now I want a burger. Great. Me too. Okay. So 20.2 feet. But where's 20.2 feet? Bring it back to your over here. So this guy is 20.2 feet. But I wanted to know the whole height. So what's my complete answer? What's the very good? The complete answer. Perfect. Some of you like anticipate my questions, which is even better. So my complete answer is, I'll type it so maybe it'll come out more clear. I need this guy. Okay, so let's see. Carlos will be 50.2 feet high after, wait, 3 seconds after passing point A. Hey, Ms. Johnson, do you want us to write our answers in full sentences? I've noticed that my students who do this practice tend not to stop here, right? Because a lot of you will get here. This is like a celebration moment, right? Like, yes, I figured it out. And then when you put it in here, Carlos will be 20.2 feet high 3 seconds after passing point A. That doesn't make sense because point A is 30 feet high. Oh, I forgot to add, right? So it is a good practice to write your answer in complete sentences. All right. Which part here, I like asking this question and I forget to ask it almost every single time. Which part here is going to mess you up during the test? Great. Focus on that point. Because for the most part, I think you guys are okay. I think once you got here, you guys were all okay. Once we got here to this triangle, you're like, oh man, this has been since like integrated 2. I know how to do this. Was it drawing the right triangle? Was it figuring out where the right triangle was, right? Was it figuring out like if it's 2 for every single one? Was it dividing? Was it the dividing part? Was it obscure? Like what part was obscure? Focus on that part. So just like anything else that you would want to get better at, you don't practice the parts that you already know. You practice the parts that you don't to get better at it, right? So at one point, I don't know, maybe a year ago, you guys were lost on stuff like this, right? But now we get to a new part and this stuff is old hat. How do we make this stuff old hat? Yeah. Finding the degree was a little bit of a monster, right? Finding the degree of theta, absolutely a little bit of a monster. But now that you know that it's a circle, you're just going to be dividing this circle into smaller and smaller pieces of pizza or pie, whatever. Does that make sense? Do you now want a pizza? Just kidding. All right, let's move on. All right, so now they want you to do the same thing, except for 1 second and 2 seconds and 3 seconds and 6 seconds and 7.5 seconds, 8 seconds, and all these seconds. So calculate the height of a writer for each of these times and represent the number of seconds since the writer has passed. A on the diagram. Keep track of the regularities you notice when you calculate this and do this. So I'm going to do probably one more of these with you just to make sure that this, actually maybe 2 more. I'll do 1 more of these with you, and then I'll pause and I'll let you guys work on this, and then I'll have you do another one. So figuring out 1 second, like look at your picture, right? Go back to this picture, right? Go back to this. Where's 1 second going to be? Where's 1 second going to be? Yeah, smack in the middle of A and B. And actually, do you know that degree, right? Do you now know that triangle, right? So if I could, can I do this for a second? Let me do this really quick. Do this. Let me copy this. Where'd you go, dude? Ah! Oh. Let me just grab this guy so I can draw all over him over and over again. Okay, let me go copy and paste. Let me put this guy back. Isn't technology wonderful? Isn't that awesome? I am awesome. Sorry. All right. So smack in the middle of A and B. I agree with you. Right? So then you would want to draw your triangle in. So here's your triangle from here. Right? There's your triangle. I probably should have used darker colors. Right? So if I pull that triangle out, right? I'm just going to move them out. No, I should probably copy them. Right? Can you label this triangle? Right? Can you label this triangle? What do you know about this triangle again? I forget. What parts do you know about this triangle? Yeah, you know the 90 degree, you know the hypotenuse, you know the angle, and you know the perfect. So go ahead and label that. So this is going to be 25 feet. What is your angle? What is your theta in this case? Very good, 18 degrees. That 18, Miss Johnson, he keeps coming back up. Yeah, right? He's supposed to keep coming back up. Right? Very good. Very good. Very good. All right. All right, y'all. Go ahead and so again, we want to use the sine equation. Go ahead and figure this one out. And then I'm going to check on it. I need the height of the writer. Don't get here and be like, whew, I'm done. No. Take a second. All right. So you all did this. Did you get an answer for this? So you figured out that the angle in there was going to be 18. This was our h that we were looking for this time. So sine of 18 degrees is equal to h over 25. Notice we have 25 sine 18. Anybody see any regularities there? So here, this is going to be 25 sine of 18. And then don't forget to add your 30 to that, right? And whatever that was, that was. What is it? Hold on, I gotta find my calculator. Oh, isn't that convenient? I already had that. So I'm just gonna copy this because why not? And then I'll go here with 18 this time, and it's 7.7. I already checked its degrees. So my answer is going to be 7.7. Don't think that that's the answer. You got to add your 30 to it. So then we got 37.7 feet. Okay. So if you continue doing this over and over again, even the 7.5 seconds, are you guys okay with the, yeah, that's fine. Are you guys comfortable with the 7.5 seconds? So 2, 4, 6, 7.5 and a half, right? Like, break that down for me really quick. 7.5 seconds, right? Where did I go? Oops, sorry. Okay, here we go. So this would be 2 seconds, 4 seconds, 6 seconds, 8 seconds. Oops, 8 seconds. So 7 would be smack in the middle, right? This would be 7. Oops, hold on. I'll wait for you, computer. Hurry. It's going so slow. Can you imagine that this says 8? And then smack in the middle would be 7? Come on, computer. I believe in you. Boom. Okay, it's not. But if this is 7, where's 7.5 seconds? This one right here. Where's 7.5 seconds going to be? What do you guys think? I need this to show up. Oh, it showed up. There it goes. So do you agree with me that this is 8? So smack in the middle would be 7. Where would 7.5 seconds be?
In between 8 and 7?
Yes. I know that sounds very obvious. But it's really important that you understand that. So it's smack in the middle of that. So I'm going to write him in pink, maybe to stand out. Right? So again, when I'm graphing this, again, take the elevator down. Draw it to here. Now, is this tiny little angle in there still 18? Is that tiny little guy from E to 7.5? I'm just labeling them like that. Is that 18? It's 9. What? Where the heck does she get 9? What are you talking about? I don't know if you're talking about. I don't know. I don't know if you can. Oh, because 18 divided by 2 is 9. So what's this whole angle then? What would your theta or alpha, what would that reference angle be then? What would that reference angle be? What would that be? This whole angle from here to here. 45? What do you guys think? 45? Yes or no? Nods of the head. Good. Where did 45 come from? 45 is her favorite number. 36 plus 9. Oh, do you guys get it? Does everybody see 36? Yes. Does everybody see the 9? If you don't see the 9, I need you to pretend that I have a piece of pizza right here. Okay. I'm going to draw you a really bad piece of pizza. Everybody ready? So I draw you a piece of pizza and I'm like, I need you to share this with your best friend. Okay. And you're like, okay, I could do that. And so you cut it in half. Everybody good? Cutting it in half? Each person gets half a slice of pizza. But then another 2 friends come and you're like, shoot, should I split it with them too? And you say, yeah. So you split it again, really splitting it in 4. Doesn't that make sense why it would be 9? Because 36 divided by 9 is 4, or 36 divided by 2 is 18, divided by 2 is 9. Everybody okay with that? So your pizza is just going to get smaller and smaller every single time. So that angle in there is 45 degrees. Okay. Could that be one of our favorite triangles? It could. Okay, so really quickly, I'm going to draw that triangle off to the side so that you guys are all comfortable with seeing this one more time. So we go here, we go here. This guy is 45 degrees. You should understand why. This is still 25 feet here. This is still my H, so I'm going to go with 25 sine 45 degrees, which again, in my calculator, it's like, man, I keep saying this thing over and over again. That's so cool. Anybody see this pattern right here? So we get 17.6 and then plus 40 would 30 would be 47.6 47.7 for 7.5. Let's see. 47.7 feet. And then the way we got that was 30 plus 25 sine 45. Okay. The last thing I kind of want to discuss was the formula that one of your classmates bossed it up with. And it's this one. I can't find my, hold on, I can't find it. There it is. They said, can we just use this formula, Ms. Johnson? Because I see it happening over and over again. So your job as a mathematician is to look for patterns. And if you look at one of the patterns that kept coming up over and over again was here in my calculator, 25 sine, and then a number, right? And these numbers here depended on the angle. So notice we still have 25, we still have 30 plus, that's not new. We still have sine. This 18t is very interesting. So t represents time in seconds. 18 represents what then? What does 18 represent? I feel like I've talked about this number before. What does this 18 represent? Very good. It represents how much, how can I put this? How much of an angle you travel in 1 second, right? If you travel 2 seconds and 36 degrees, that implies that in 1 second you can travel 18 degrees. Does that make sense? So this is actually really good. The only thing I'd add to this formula is a minus. Now the minus comes in when you're below the x-axis, but other than that, it's pretty darn strong. So you would have been able to see this. Apparently your classmates saw the pattern super quick. That's your job in math. Your job in math is to look for patterns. When you are good at looking for patterns, your job of efficiency becomes like super nice. Like, oh, I don't have to draw my picture every single time. I'm just going to plug it into here and figure out where he is. I will add when he's above the x-axis. I will subtract when he's below. Okay. So I'm going to have you finish this chart because now you can check all your answers. Make sure you check them against, your number line here, right? Okay. All right.